So, like as I mentioned, the agenda for today's session is we'll be discussing on 2D arrays or multidimensional arrays, or another name for this is metrics, right? Real life examples in coding scenarios would be like whenever we are using images in the background, images are basically stored metrics as matrices of pixels, right?
Yeah, yeah.
Yeah, so one example would be images. Another example, so like if you have to design a chess game, that would again be a matrix of 8 by 8,
Yeah,
right? 8 by 8
yeah.
matrix. Uh, Similarly, there are multiple examples. Let's say if you have played tic-tac-toe, so that's another example. So these are some of the examples where we used to see the multidimensional arrays and matrices, right? Let's see how it is represented. So in order to define any array, any multidimensional array, let's say A, we need to know two things. Or the first thing is the number of columns. Let's say this matrix has m columns, and let's say it has n rows. So this is an n cross m matrix. If m is equals to n, then this is known as a square matrix. Otherwise, if m is not equals to n, then it's a rectangular matrix. Let's look at Java. Like in Java, how do we define a multidimensional array? So this is the syntax. I'm just writing the syntax. If you have to define a 2D array with name A, we just write new. We define what are the data type of the elements that would be stored. So let's just say A store integers. So in these square brackets, we first write the number of rows, and
Yeah,
second
in the
bracket, we
column.
write the number of columns. Yeah. So this is the syntax for Java. For JavaScript, as we mentioned in arrays, in the lecture of arrays, we saw that in JavaScript by default, the arrays are dynamic, right? So in these low-level languages like Java, C, C++, we need to know the size of the multidimensional array, just as we need to know the size in arrays. But in JavaScript, we do not require to know the size of the array. So you can just
And
define
actually,
a multidimensional array, right? Like new, you can leave this bracket empty. And if you want to define it as a multidimensional array, what you can do is, or let's just say that you are first defining it like a normal array. So what you can do is, so when you are defining an array in JavaScript, you mention the size of the array, right? So here, let's just stay with me. Let's say that I have written 3 here, but I need 2 dimensions, right? I need
yeah.
n and
How
n.
do we know?
So
Yeah.
So you can simply just do it like this. I less than a dot length, which in this case is 3, I plus plus, and you can just simply say a of I, and here you define it again as an array. And in this case, whatever you would write here would be the size of the number of columns. Let's just say I say it would be 4 for all the rows. So this would result in a matrix of 3 rows and 4 columns. Does this make sense?
No, I'm not getting it.
Okay, so what we have done is we have first
Should
defined
we
a matrix A, and this is just the syntax of JavaScript.
should we always like define the column after we write the for loop? Like,
So this is
is
like
there a
I'm not.
way actually to define like?
Yeah, you can define it like I'm just saying that as we saw in the previous session that when we define arrays in JavaScript, they are by default dynamic, right? So you can first define an empty array, and then in future you
You
can.
can actually push. Yeah, you
Yeah,
can actually push everything. But
yeah. So that's what we are doing. In this case, this defines the number of rows that you would have in your array, right?
okay.
And when you run this for loop, so you are basically iterating through all those rows. So we are iterating
Yeah,
all through all those rows, and for every row, like this a of I would be the zeroth row in the first iteration, right? So we are defining for the first iteration for the zeroth row. I'm saying that my zeroth row would contain another array. Can I just say this that this is nothing but
okay. Yeah, I see
yeah.
it now. Okay.
what I'm trying to say is that this matrix is a
So
group of
every
3
row
rows.
has actually
Yeah.
a 4 column. Yeah.
Yeah. So in the backend, that's how JavaScript is writing it. So this is just the syntax of Java and JavaScript. Whatever language you are using, you can respectively do it in those languages. Now let's try to look at if you are given a 2D array. Let's say that you are writing a function and that function is accepting a multidimensional array, right? So if you are given a 2D array, in this case, how would you know what is the length of rows and columns if you are given just an array? So how would you calculate the number of rows and columns?
You can actually accept from the user as
Uh,
n.
yeah, we can, but what we would just see is that we do not need to separately ask them for the length of rows and columns. We can derive it from the given matrix itself. How would you calculate row length and column length? So let's just say a function called image, and this is accepting an multidimensional array. Here in this case, first in order to get the number of rows, how I can get the number of rows is by simply writing a dot length. So in case of Java, it would be a dot length. In C++, you might be having any function regarding whatever you use to find the length of arrays. You can simply use that to get the length of the rows.
Yeah.
And then how would we intuitively are you getting any idea how would you calculate the number of columns if you can find the number of rows?
We can actually iterate through the first row and multiply it like
Yeah,
using
definitely. We do not have to multiply. You just have to say that a 0 dot length. This would give you the number of columns because whatever the length of the first row would be, yeah, that
the
would be the
column.
length of all the rows. But there is a little thing to note here. Let me just write a statement. I'm claiming that whatever the length of first row or zeroth or
Yeah.
like all the other rows would be having the same length. But is it necessary that all the rows would have same number of columns?
I think maybe otherwise maybe null or
So all these rows have 5 columns, right? First row again have 5 columns and similarly all.
yeah.
But can I not have an array like this, a multidimensional array like this? In this case, all rows have different number of columns, right?
Yeah.
So in programming, this is known as something as jagged array. Jagged array. J-A-G-G-E-D.
Okay, jagged
array.
array.
Yeah.
I've seen it in C#. Yeah.
Yeah. So this is called as jagged array. But when we say multidimensional array, that means that we are talking about multidimensional arrays that in which all the rows have same number of columns. When we are talking about multidimensional arrays. So this is just something that I wanted to touch, but we would not be looking at them right now.
In what is the jagged array?
I'm sorry, were you asking anything?
In what situation?
Okay, so in what situation can we use a jagged array?
Yeah.
I have not yet experienced any scenario in which I can use jagged arrays, but I have seen plenty of interview problems where we can use jagged array. But definitely there would be some good examples where we can use jagged arrays. So I think one of the example could be like when you define a graph, right? So let's say you are defining a stock related app and you want to store that information in a data structure. So there are 2 dimensions here, right? So for every m, I can have this sort of a structure, right?
Yeah.
This might not be that intuitive, but there could be some reason, some examples where we can use jagged arrays. When we talked about arrays, we saw something as random access, right? Can we have random access in multidimensional arrays as well? So what random access meant?
You mean like using the index?
Yeah. So
yeah, we can actually write the index of the row in the column, and we can actually get the value.
Yeah, that is actually the accessing part. But what random access specifically means is that because I have continuous memory, like the way I am storing the array elements is in continuous form, right? That is the
Yeah,
reason why I was able to take the advantage of random access. And that means if I want to find the ith index, I could do that in order one time complexity was because I just have to get the base address of the zeroth index and then add the
you
ith
can add,
index
yeah,
times times the size
yeah.
of the index, that is, since we are adding integers, so this would be 4 bytes into whatever I is. Similarly, like when we are talking about multidimensional arrays, how would I take the benefit of random access here? Because in order to have random access benefit, I need to store the elements in continuous memory, right? So see, this is the
Yeah.
zeroth row, first row, second row, third row. I can, like when we looked at the way we define multidimensional arrays in JavaScript, we saw that I can simply say it as a collection of 4 rows, right? So like in every row, I know I can store these elements continuously, right? But how would I get from this element to this element? Are they also stored continuously?
No.
So let's just try to see how actually this works in memory. Let's say this is the RAM, and let me divide it into, this is 4 into 4, so this would be, so it's 4 into 4, so there would be 16 elements, right?
Yeah.
1, 2, 3, 4, 5. So since what we are claiming is that this from 1 to 4, we know we can store them in continuous manner. From 5 to 8,
Yeah.
we can store this again in continuous manner. Similarly, from 9 to 12. This is exactly how we can store a multidimensional array also in 2RAM. So what I'm doing is, after 4, the next element, I'm actually storing 5 here. So in this case, again, like in multidimensional arrays also, I can store this in continuous form. So if I have to fetch, let's say, this element, what would I write here? How would I get the element 11?
11.
Yeah, so this is second row, right?
Uh,
And second column.
Second row, second column. Yeah.
Yeah, second row and second column. So this is how you can access an element in a multidimensional array, just by defining the in what
Yeah.
row it is and in what column it is.
Column. Yeah.
So just as we saw in arrays, I can take the base element here as 0, 0. So I can take the address of the base element, that is a comma 0, 0, and I can add like, let's say, since we are storing integers, so every block would be 4 bytes, right? Each of these blocks would be 4 bytes. So I can say 4 bytes, but now I have two things here. One is I, one is j.
Yeah. The rowing column.
Yeah, so earlier I was just simply multiplying the size of the element by I, but here I need to multiply it with something different. Yeah, this is j, this is I. Uh, can I say, in order to find the address of this 11th element, I just need to know how many elements are before this, so that I can get the base element and then multiply like the number of elements before 11 and then just multiply it with the size 4 bytes. In order to calculate the number of elements, like intuitively, I can just see that there are these two rows combines of total 8 elements and then this 9 and 10. So there are total 10 elements before this 11th, right? So I can say a of 0, comma 0 plus 4 into 10. Would this give me the address of this 11, a2, comma 2?
How do you actually like adding?
So 4 is the size of every element, right?
Yeah. Yeah.
And we just need to find how many number of elements lies before 11. What is the distance between the base element and this 11, right?
Yeah.
That's what I need to calculate and then multiply that by the size of each element, right? Wouldn't that give me the distance? Let me write it here again. Look at it as a physical block. Like you are going from one place to this place, and these are the number of blocks that you have to travel in order to get to this place, right?
Yeah.
So what we can do is I can calculate the distance, like what is the length of this single block. Every block is of length 4, and then I can simply just multiply whatever how many blocks are present just before 11, right? So in this case, 5 plus
Okay.
5 plus 2. So I can get the address of this. So the address 0, 0 plus uh, the length of each block times the number of blocks. Does this make sense now?
It makes sense, but how do we actually doing the
Yeah,
operation?
yeah.
Like
That's what we are going
adding
to
it.
look at now. We just need to know this, right? Then how many number of blocks
Yeah.
are there? Yeah, let me say this. Let me write it here. So A of ij uh, in this case would be how many rows are there before this, right? How many rows are there? There are two rows, right?
Yeah.
And how many columns are before this? Three
Three.
columns.
Yeah.
Yeah. So if I just write the indexes here, and what is the index of this 11? It is A,
A
second row,
two, a
and
second row and third column.
yeah, and third
Yeah.
column. So my I is 2 and my J is 3. So
Yeah.
I would get the base index 0, 0. This is what I know, right? This is what I know. Plus I would do 4 into, now this is what I need to calculate. Can I say it is the number of rows times the number of columns? Number of rows before this element. So there are two rows before this elements. So I times whatever are the total number of columns. So there are 5 columns, right? 5
Like one.
plus j. Because if I do I times 5, this would give me the total number of these elements, right?
Yeah.
And then j is 3. So that would give me the number of columns before it. So that would give me this, right?
Yeah.
Okay. So that's basically what we're trying to do to access any element. So this is again an order one operation, right? Because we are
Yeah.
simply just adding, right? We know this,
Yeah.
and then we are doing some computations. I'm not iterating, right? So this is order one time
Yeah.
complexity. If ever you are asked in an interview, like what is the time complexity of accessing any element in a multidimensional array, it would be same as in arrays. It would be of time complexity order one. Okay, and now just
Is this the
let's.
only way, like, to access?
I'm sorry.
Is,
We're trying
is
to.
this the only way, like?
Yeah. So this is how it works. Like whenever you are trying to access any element in an array, like this is just the computation that your compiler does in the backend, like behind the curtains. You don't need to do this every time. You just have to write, like if you want to get the value of any index, you just have to write what row and what column it is, and the value would be stored in any variable. You can store this value into any variable, right? So this is just for the understanding point of view. We do not have to do this calculation. Okay, now just let's just quickly look. How can I iterate over all the elements in a multidimensional array?
We are actually maybe using nested loops.
Yeah, right. So let's say I have a 3 cross 3 matrix and I want to print it in this order: 1, 2, 3, 4, 5, 6, 7, 8, 9. Right.
Yeah.
Um, let's quickly write a code for it. Less than the
The size of the row.
yeah number of rows. X plus or
J. Print. Yeah.
so this would just print it in this order, right?
Yeah.
But now let me uh, change this a bit. This was the array, and now the question says that I have to print it in this order. So 1, 4, 7, 2, 5, 8, 3, 6, and 9. Would you like to try it on your own?
Maybe I can try it.
Yeah, it will take a minute and
Give me some minutes.
yeah.
Yeah. Okay. I can write it in C++, maybe.
Uh, yeah, now, do you need some more time or shall we do this together?
Maybe do it together.
Yeah, okay. So where were we? Yeah, we had two printed in this order now. So let's just try to understand what was happening in this previous case. So let's first try to look at this inner loop. What are we trying to do in this inner loop? We are iterating in a single row, right? So in this inner loop, for the like in the first iteration, I would be zero, right? I would
Yeah,
be zero. So this would be the first row.
the first.
Yeah, and what we are trying to do is for the first row, we are iterating through all the columns from j is equals to 0 to n.
Yeah,
So in the inner loop, for the when I is equals to 0, what I would print is 1, then 2, then 3, right?
yeah,
This is what the inner loop would print when I is equals to 0. When I is equals to 1, now I am in this first
yeah.
row. First I was in zeroth row, now I am in first row. And in this row, I would print 4, 5, and 6. Because first I would print j is equals to 0, j is equals to 1, j is equals to 2. And when I is equals to 2, that means now I am on the last row, second row,
Yeah.
and I would print 7, 8, and 9. Okay. So this makes sense. Now what we have to do is I have to change my inner loop in a way that such that first I start with the first column and I iterate over all the rows in that first column. Then I move to the second column and I iterate over all the rows in that column. So wouldn't I just do this? I would just make my inner loop my outer loop and make my outer loop my inner loop. So let's see how that would work. For int j is equals to 0, j less than m, j plus plus. This is our outer loop, and this time my outer loop would iterate over all the columns. So from j is equals to 0 to j is equals to m. These are the number of columns. These are the number of rows. And in the inner loop, when j is equals to 0, I would get into my inner loop and traverse through all the rows in that column. I would simply print ai comma j. Can you see the difference in both the codes? What you have tried to do
I
in the
got that
first?
one, but I haven't seen any difference. Can you give a graphical demonstration about like
Yeah, sure. Let's look at this example. This is a 5 cross 5 matrix, and what we're trying to do is print the elements in this
in
way,
the
right?
first column?
Yeah,
Yeah,
column wise. Okay. So how would I go about doing that? My outer loop should run through columns, right? So this is the number of columns, m. My outer loop should go from 0 to, and like when j is equals to 0, that means I am at the first column, right? So
yeah,
let's try to look at it in this way. When j is equals to 0, I am at the first column, and for that, now I would move in my inner loop, and my inner loop would run from less than n I plus plus. In this case, when j was 0, that means I'm at the first column, and now for the first column, I have to print all these elements, right? So I
yeah,
would go through all the rows in the first column. So in my
yeah.
code, what I
Zero,
had
zero.
written was I comma j.
Yeah,
But now let's just look how this would run 0 comma 0, right? In
yeah.
first case, it would print this. Then the inner loop would go to 1, and my outer loop is still at 0. Then my inner loop would go to second.
Okay.
My outer loop is still at 0.
Still, yeah,
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 that's
yeah,
2.
yeah,
So I have covered all the elements in the first column, right?
yeah.
Uh, Now, once my inner loop has completed, now I would now my outer loop would increment to j is equals to 1, right? So I would move to this column, right? First column. And again,
Yes.
similarly, all the elements would be printed, right? Does this make sense?
Yeah, yeah,
So if this is clear, I think we can go to the first question of today's session. So like this question was asked in all the big companies. It was asked in Amazon. It was asked in Google. it was asked in LinkedIn. So when it comes to multidimensional arrays, this tends to be a very important question. So what it says is you have to print a given matrix A in spiral form. So what does it mean? Let's say this is the matrix that is given to us. So what does uh, the question says? I have to print it into a spiral form in clockwise direction. So if nothing is mentioned, you can always assume that you need to print it in clockwise direction. So okay, and similarly it would go like this, then this, and finally you would stop here. Start from here, you would stop here. So this is the way we have to print our code. Let's see how it would look like, how the output would look. 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, and so on. Right? How can I start? Like, what is the first intuition that I can get if I try to make an algorithm out of it? How do I even start? Yeah, this is a medium to hard level problem. So what I would suggest is whenever these kind of questions are given to you, try to picturize it. So in this case, let's try to roughly write the steps that you can see. Yeah. So yeah, pseudocode. So in the first step, what we are doing is I'm iterating over the first row, right?
Yeah.
And I'm going from left to right in the first row, right?
Yeah, right.
In this direction. In second step, I'm in the rightmost row. So in the right row, and I'm iterating from. Am I iterating from top to bottom?
Yeah, actually the same scenario.
Yeah. No, actually I am iterating from top plus 1 to bottom because I have already covered the top from in this first step.
Yeah, we are
So in this second
yeah.
step, I would iterate from 8 to 16. So top plus 1 to bottom in this direction. Similarly, in the third step, I'm in the bottommost.
Yeah.
And I'm going from, can you tell me
Right.
from where to where?
Right plus 1 to right.
No, right minus 1, right?
Minus 1.
I'm going from 15 to 13. So it would be right
Yeah,
minus
minus
1
1. Yeah, it's 1
to
plus
left.
to the left. Yeah.
Yeah. And finally, in this last step, I would go like I am in the leftmost row, sorry, left column. Here I am at right column instead of row. Top row, right column, then bottom row, and finally in the leftmost column, right?
Yeah.
From 13 to 5. So it would be bottom minus 1.
Yeah.
Yeah, because I'm going from 9 to 5.
Yeah.
It would go till top plus 1, and this is in this direction. Let me just write one more step. So like doing these 4 steps, I have traveled the outer spiral, right? Now I have to go to the second in the inner loop. So you can look at in labels. So I can say that I have in the first 4 steps, I have traveled the first level. Now I'm moving to the second level in the inner shell. So if I go to the next step, what do you think? Where are we right now after this 5? In which row am I?
Left plus 1, 2.
Now I have to again travel in the row, right? So I'm again back to the first step, right? But instead of top row, now I am at top plus 1 row, right? Does this make sense? Yeah.
Yeah.
So in the fifth step, I am at top plus 1 row, and I'm going from left plus 1, right? Left plus 1 to right minus 1, right?
Yes.
Left plus 1 to right minus 1. Then this section. And similarly, and so on, right? So if I tell you that you have to travel in a certain direction, after a little practice, you can do that, right? Since we have seen in this previous example that we can easily travel the rows like this and we can travel the rows like this, right? Now, if I can do this, all I need to take care of is I need to keep a track of the rows on columns that I have already traveled so that I do not travel them again, right? I have traveled the first row, so now I need to keep a track somehow that I have traveled through this row and I do not need to go through this row again. After that, I have traveled this last column, rightmost column. So once I finish this rightmost column, I need to discard it, right? After
Yeah,
I
you can read.
travel this bottommost, I need to discard it. And similarly, after I have traveled this leftmost column, I need to store it in some way that I need to retain this information so that I do not accidentally go over them again. Okay, so if this makes sense, let me write the code. And while writing the code, we will try to understand this problem, right? How we are doing this. So if I have to start writing the code, there are four variables that I need right now. One would be top, one would be right, one would be bottom, one would be left, right?
Yeah.
Before starting the loops, what would be the value of left? It would be zero, right? The value of top would be zero.
0,
What would be the value of right? Let's just say there are m
1, 2,
columns and
3.
there are m columns and rows. What would be the value of right before starting the loop? Wouldn't it be
3.
m minus 1?
3, I think.
Yeah, m minus 1, right? And similarly, you need to tell me what would be the value of bottom before starting the loop. Wouldn't the last row be n minus 1? There are total n rows. Yeah. So now we have defined their initial values. Now I can go into the loops, right? So what was our first step in the pseudocode? I am at the top row and I have to go from left to right, right?
Yeah.
So let's try to write that. In our first for loop, I'm starting I from where?
0.
I'm in the top row, but I'm starting from left and going to right, right? So this is the first step, starting from left to right. So I would start from left till I is less than equals to right. Now in this, I just have to write the print statement, right? But in this print statement, I need to write on what row I am right now and in what column I am in right now. What would I write in place of row? Wouldn't it be top because I'm in the top row?
Yeah.
And in place of column, since I'm going from left to right, so in every iteration, my I would increment from left to right.
Yeah.
So if I write this statement, this means that I am in the top row because in this case, my row
Printing
is
the first
fixed.
row, yeah.
Yeah, my row is fixed, but my column increment is changing.
Yeah.
Right.
Yeah.
So top I, and once I have done this, there is still one more thing that I need to do before moving to the next step, and that is increment top one plus plus increment top by one. Does this make sense? Because this means that I have covered the first row, that is the top row.
Yeah.
And initially top was zero. So after completing the zeroth row, I need to increment it so that when I come back again, I do not
count the 4. Okay.
Once we finish the code, this would make more sense. So with this loop, I have traveled successfully through the first row. Now in the second step, I'm at the rightmost column and I'm going from top plus 1 to bottom, right?
Yeah.
So my for loop would start from I equals to, I'm going from top, yeah, because I have incremented top here. So I would just write here top. Now top is 1. Initially top was 0, now top is 1. And now I is less than equals to bottom. I'm in the rightmost column. In second step, I'm going from 8 to 16.
8 to 16, okay.
So top to bottom, and I would do I plus plus. And now you have to put a little strain on your mind and tell me what would come in this. Just try to find out what is fixed in this place,
Yeah, okay.
and what is incremented. We are here. So we are traveling through the rightmost column.
Yeah, the column has to be fixed. So maybe the bottom.
A column is fixed, right? So I would, and which column it is? It is the rightmost column, right?
Yeah.
So column is fixed and my I is changing. I is going from top to bottom. So
yeah,
here it would come I. And since I have traveled through the right column, I would do right minus minus in this case, right? Because I have completed this column, my next column would be this. So I would do right minus minus.
Can you actually make the cursor point?
Yeah, let's do that. So in this step, what we have done is we were in the rightmost column, right?
Yeah,
We're
8 to
traversing from
16.
8 to 16.
Yeah.
But since we have covered this, after completing this, what I would do is I would decrement the value of right. Right now, the value of right is this 3. It is in the third column.
Yeah.
So I would shift to this side, right? So I would decrement r by 1.
By,
So it would be
by
r
okay.
minus 1. Yeah.
This one. Okay.
Next, we see in our pseudocode, what we have done is we are in the bottom row and we are going from right minus 1 to left. Since we have already done right minus, I do not have
Minus
to do
1?
that again. Yeah.
Yeah.
So in this case, I'm going from int I equals to right, I greater than equal to left, and I minus minus. In the first two loops, we were incrementing. In this loop, I am decrementing because I am going from here
Right to left.
to here. Yeah, so I would decrement in every step until I am greater than equal to left. Right now, left is at 0. And now I have to do write this print statement.
Now the right has to be.
Yeah, can you tell me what would come in
0
this?
has to be fixed, so.
Yeah, we are traversing here. So what would be fixed?
0 will be fixed.
Yeah, bottom. We are at bottom row. So bottom row would be fixed. So if row is fixed, row comes in the first place, right? So it would be bottom. And since I'm traversing through all the columns in the bottom row, this would be I. Once I finish this loop, I would do bottom. What should I do? Bottom plus plus or minus minus? Right now, bottom is 3.
Bottom is 3. So after that, we are actually going up. So I think bottom minus minus.
Yeah, right. This bottom minus minus. And now in the final step in our pseudocode, we are at the leftmost column. We are at this column, and we would go from 9 to 5.
Yeah.
We're going from bottom to top. So this loop would be int I equals to will be bottom and I greater than equals to top. I minus minus. And in this case, what is fixed?
The column is fixed.
Yeah, which column?
The bottom, the left one.
Yeah, the left column. Left. So it will be left. And in the left column, I'm going from bottom to top. So this would be the last loop. And finally, I would update my left column. This time it would be plus plus. Because I am at the leftmost column and now I have to move in the right direction, right?
Yeah, to the 6. Yeah.
Yeah. Okay. But our code is not done because right now we have only traversed the the outermost.
Yeah.
So these 4 loops would come inside a while loop. I have to run a while loop. And now let's try to understand like what would be the conditions in this while loop. So
what do you mean? Like all the loops have to be running?
Yeah, all the loops have to come in this while loop. These all 4 loops are independent of each other, right? They are not nested loops. Yeah.
So why would we have to include the loops in while?
Yeah. Because in this for loop, I have only traveled.
They are not infinite. They're not infinite loop, but yeah.
No. We would write the for loop in such a way that it would stop after a point. So that's what we are discussing right now. What would be the conditions of this while loop? Let's try to look through our steps. In the first step, we are we are on the top row, right? and we are going from left to right. And similarly, in the second step, I'm in the right column and I'm going from top to bottom, right?
Yeah.
Or top plus one to bottom, to be precise. In the next step, in the third step, I'm at the bottom row and I'm going from bottom minus one, right? Let me just write it b minus minus to save some space, and I'm going till left, right? Sorry.
I think it's not.
Yeah, it is right minus minus. Good observation. We're going from right minus minus to left. And finally, I'm at the leftmost column and I'm going from bottom minus minus to top plus one, right?
Yeah.
But after doing these four loops, still I have only completed the outermost shell.
Yeah.
I now have to go to the second spiral.
Yeah.
And in order to do that, I need to involve all these four loops into another loop. And this loop would be a while loop. And what would be the condition of this while loop? Let's try to look at it. Can I say this that
so we are not actually creating another loop, like we are using the same loop?
No. After we finish the first spiral, now I have to go to the inner spiral, second spiral, then I have to go to the third spiral, then fourth spiral, until a certain point, until a condition is met. And now we are trying to look what is that condition.
Again, okay.
Can I say that in my first loop, I'm doing top plus plus? There are two things that are incrementing and there are two things that are decrementing. Top is incrementing, right? After every loop.
Yeah.
I'm sorry, there is one difference. This top would come outside this for loop. Once this for loop is completed, after that we would increment this. Like I'm trying to make a statement. I'm saying two things are incrementing and two things are decrementing. First thing that is incrementing is top, right? Top is incrementing after every loop. Right is decrementing after every loop, right? Bottom is decrementing after every loop, and left is incrementing after every loop. So can I say if this is my matrix, this is my left column, I'm starting from here. This is my top row, this is my rightmost column, and this is my bottom column, bottom row. After the first loop completes, I'm incrementing my top, right? So I'm doing top plus plus. After that, I'm going through my rightmost column, and once my rightmost column completes, I'm doing right minus minus. Then bottom row completes, and I'm doing bottom minus minus. And finally, my left row, left column completes, and I'm doing left plus plus. So if you look at these two things together, top is incrementing and bottom is decrementing. Top is moving in this direction, bottom is moving in this direction.
Yeah.
Can I say that my while loop would run till my top is less than bottom? Can I say this? Because if I keep on doing this, there would be a point when top would equal to bottom, right? And after that, if I keep on doing this, bottom would keep going up and top would keep on going down. But we need to do this till we meet the center of this matrix. And the center of matrix would be the point where top is either less than bottom. So if the number of rows are odd in the final step, top would be equal to bottom. If the number of rows are even in the final step, top would be less than bottom, right?
Okay. Yeah.
And now let's try to look at these two things together. Right is moving in this direction and left is moving in this direction. So my second condition would be left, we would run the while loop till left is less than equals to right. Does this make sense?
Yeah.
Okay. So this makes sense. After the first, we have four for loops here, right? After the first iteration, we have covered the outermost spiral, right?
Yes.
Now the right would decrease, left would increase, top would increase, and left and bottom would decrease. So we would move to the second spiral.
Yeah.
Again, in the next iteration, top would increase, bottom would decrease, right would decrease, and left would increase. Similarly, you would keep on doing this until this condition
if
is
the condition is
matched.
false.
As
Yeah.
soon as this condition is false, we would stop our loop and our spiral would be completed. Does this make sense?
Yeah, it makes sense.
Okay, so it was a big achievement. Like if you completely
Yeah.
understood this question, this is actually a medium to hard level question. So it is.
Can you actually screenshot the
Yeah. I would
thing you write and
provide
share
this
with me?
entire video in the YouTube, and I would like I
No,
think
I want
it is.
actually the demonstration, the
Yeah, I
screenshot.
think this file. Yeah, it is in OneNote, so I can save it. Okay, I would share this in the group as well. I think today's session is done. Tomorrow we would be looking at more problems, like more problems that are asked in these big companies. So let me just quickly give you at the first problem that you would be looking tomorrow. It is known as rotate image. Like if you get time, try to
Okay.
look at this problem beforehand. We would discuss it tomorrow. And what does it means is that you are given a matrix A, and let me say these are the elements in this 5, 6, 7, and 8, 9, 10, 11, 12, 14, 15, and 16, and you have to rotate this image 90 degrees clockwise. So the final state would be try to imagine it as a Rubik cube, right?
Yeah.
So if you rotate it 90 degrees, its final state would be
13.
13 would come here, 9 would come here, 5 would come here, 1 would come here, 4, 10, 6, 2, 15, 11, 7, and 3, 16, 12, 8, and 4. Like we have to rotate our image to get this final matrix. So I think the today's session is complete. Tomorrow we will be looking at 2 to 3 more problems. If there are any doubts in today's session, you can let me know now.
Good. Just like save the file and share with me.
Yeah, sure. Okay, thank you.
Thank you very much.